You are certainly, hopefully, at a place, having been tested by me, that you're really doing your homework. How I always use the capital REALLY, that you're really processing it. Even though you have so many resources to just copy it down from somewhere. Hopefully, you're really, really processing it. What page? 306.
306.
Okay, so does anybody have questions on their homework that they felt kind of unsure about? Okay, great. Caroline?
You did 33.
All right, this is 33. So also, I may do it a little bit differently. So, and by the way, y'all remind me, if I don't do the integral of sine 2x, cosine 2x before I hand out this topic for today, just keep reminding me that was where I kind of ended the last class, and I want to do that today. I'll get you just a second, Grace. Caroline, I'm on number 33.
Yes, please.
All right, this is page 306, number 33. And we can also discuss if you did it a different way. Grace, question before I start?
Is there like an easy way or like a trick to know if you should use substitution
Yes.
or not?
And a lot of it comes by experience with your gaining right now. Can y'all see the slide okay? I'll probably be black myself. All right, yes, Grace, and we'll continually talk about that, okay? 33, oh good, okay. It's the square root of x squared. You may have seen in your homework assignment, I think I still transferred it from my syllabus into the homework assignment. Always try to reduce it first, which is kind of goes to Grace's question. Plus 5x minus 8 over the square root of x dx. You can tell by all of your assignments that I give you in this book, as opposed to like if you were in like Algebra 2 or some course where you didn't get many textbook assignments, or a pre-calc book in our calculus books, I like a lot. Larson's like, you know, to be quite honest, I didn't even want to teach out of the Larson text. Now that in January I can share this with you. I wouldn't want to just do it at the beginning of the year, but it's such astute, above board calculus text, and I had taught out of a bunch of different other authors that I kind of hesitated to teach Larson. I'm like, oh, Marty Larson, he's really, really tough. Ironically, when I became the AP Calculus BC teacher at White Station in Memphis, they were using this text. And then when Mary Mount called in October, I'm like, we need a teacher in November. Never mind the question I've always wanted to ask is, why don't you already have someone if you're in New York City anyway? And now that I see the faculty that's here, I'm like, anyway, I've never asked. But be that as it may, in accepting the job and then communicating with their current AP Cal BC teacher, the wonderful Kyla Edmonds, who's fantastic. We were at the same textbook in the same place using the same worksheets. It was such a great segue. So I'm so glad they were using Larson, because I love it. It'll really, some of you will see it in college. In any event, another thing I like about it, which brought on this big speech, is that they don't just give you substitution questions in the substitution assignment. They build it up to where we do what Grace is saying, we make decisions. You know, one thing I told you about a friend of mine, Miss Gates, who I just like basically worship, she, you know, would always say, and I would say it to my students, like, please don't just try the topic that you're learning, or don't try what it just immediately looks like. Like once you learn integration by parts, you'll see, I'll bring it up to you, you'll be tempted to go, oh, well, I'm doing homework in integration by parts, whereas substitution would be the best way to work the given problem. So right now, most of your homework is on substitution, but your first thing you should always do is try to simplify it first, or just see if you know it. So please don't just do, when you look at any integral, your thought process should be the order in which you learn the topics. Right now, you kind of have a safety net of all you know is either you've reduced it, or you've memorized it, like sine and cosine, or something like that, or substitution. Next, I think we'll learn integration by parts. And so when you're on the parts homework, you should try to reduce it. Then you should try, kind of reducing and memorizing kind of are the same thing. Then you should try substitution. Then you should try integration by parts. So I'll help you with those decisions. But every one you look at, see if you can reduce it. Don't jump into substitution. Whenever you have a single denominator, you just want to reduce it. Like this is x squared plus 5x minus 8 over x to the 1/2. Please do that. Okay? And then it becomes just an anti-power rule. And Grace will actually do an exercise today or Wednesday that actually I'll give you, like, we'll look together at 4 problems and go what would be best to do here. Okay, and now I'm going to subtract my exponents and get x to the 3/2. This can be 5x to the 1/2 minus 8x to the negative 1/2. So Caroline, do you see how you want to approach that from now on?
Yeah, so you
Okay.
just didn't need to do substitution.
No, this did not
Okay.
require
I
substitution.
did not know what to
Are
substitute.
they okay adding, well, you wouldn't even want to anyway, but it takes some time to get used to making your decisions, okay? But it's just like, you know, in med school or law school or anything, you learn all these different situations and then your gut instinct goes with, what do I do now? Anyway, are you okay from here on out? Add 1 and divide. Another thing that brings this up is, I think this will happen to you, and I think y'all would have the same question. So, I don't know why it requires me to do this twice. Okay, so suppose I have something like this, the integral of x plus 4 over, let's say, x minus 2. All right, it's not what I've memorized. You're never going to have an anti-quotient rule. My first thought is maybe I could let u be x squared plus 4, thinking ahead that would give me 2x dx, and maybe I could pull that off. I don't even think I can make the pieces of substitution work here. You'll get to where you can kind of think about sub in your head. However, that shouldn't be your first thought here. You also can do long division, okay? And I don't know that you'd ever do synthetic division here unless you're doing like math team stuff, okay? But in this class, you're probably just gonna go with long division. The reason not synthetic division is so often you're not, you don't even have a linear factor. Like for instance, if this was I was doing synthetic division, I would put 2 in a little box even if you remember synthetic division. But if I have x cubed and x squared, I can't do synthetic division anyway. So I gotta prepare you for what you would do in any event, okay? And so if the top's 1 degree, or if the top is any degree higher than the bottom, almost always you'll just go to division, okay? So x cubed plus 0x squared plus 0x plus 4. Do you remember compensating for 0 coefficients? You have to do it in the dividend and the divisor. So I'm gonna make this x squared plus 0x minus 2. If you don't compensate for every single component of the polynomial, you'll find out when you try to divide, things won't line up and it'll remind you itself. So, you know, in this room with these minds that I'm teaching, you'd be okay with that, right? Other people might need a little more explanation, but it just wouldn't even line up. You go, oh yeah, I forgot to put in my 0 coefficients. And I know you don't want to do this, but it's really not bad. Those things that we used to kind of hate aren't so bad because we've done things that are so bad, okay? What are you going to do for x squared to get x cubed? I'm going to multiply by x. So that gives me x to the 3rd plus 0x squared minus 2x. And then you subtract, but I'll forget to subtract somewhere down the road. So I physically do this. I just change all the signs and add so I won't forget. That's what I do. These cancel. These would have possibly given me an x squared, but it doesn't. And then I have 2x plus 4. And so that's my remainder, 2x plus 4, because I can't make x squared go into 2x plus 4. And so now my answer is x plus 2x plus 4 over x squared minus 2. Now since I just made this one up off the top of my head, we'll see some that are better than this one that I just made up. I don't even know if I can integrate the rest of this, okay? Usually what happens, it becomes just like a polynomial that you can integrate all the pieces like Caroline and I just talked about, okay? This one I could if I let u be x squared minus 2, I might manipulate it to, I think I could do this. Integrate x plus the integral, now back to what Caroline and I were talking about, 2x over x squared minus 2 dx plus the integral of 4 over x squared minus 2 dx. Now, I definitely can integrate this piece. Do y'all see how these had a common denominator? I can definitely integrate this piece with substitution. I could let u be x squared minus 2 and du would be 2x dx. This part I actually don't know what I'm going to do with. I would have to, brainstorm about other techniques I'm going to teach you, but right now you're not equipped to do the last one. Okay? But like I said, I just made it off the top of my head. Many of them you would do long division, but my point is, in doing both of these on the same slide, is I'm dividing in both instances. That one I can just divide. If you have a single thing in the bottom, just start putting it under everything. But I also wanted to do the case where you might run into something like this, and you can put 2x over this part and 4 over this part, and you can start to break it up with a common denominator after long division. And we'll stop a lot and look at problems where we even just say out loud the decision we would make, because you're going to need some guidance in that. Right now your choices are, you either know how to do it or you're going to try substitution because you don't know how to do it. Those are your two choices. But bigger choices are coming. Not today. All right, great question, Caroline. That also plays into 35 and 37. You just want to distribute on those, girls. Those are not substitution problems, but you should try that first. I can't say it loud and strong enough, okay? If I had a microphone, I would get a microphone and say, try algebra first. Don't try substitution first. All right, any other questions on homework? All right, Anna?
93.
Okay, so 93, and why do they have the right to ask us for area on these problems? Thank you, very good. They don't really have the right to ask me area in the way that they're asking. We'll study area in and of itself later. It looks like I'm integrating this from 0 to pi, and we have 2 sine x plus sine 2x. I'm a big fan of standardized test taking skills, in other words, critical thinking. And so I know this thing looks like this from 0 to pi, and the highest it goes is between 2 and 3. Now, you may be a little surprised that a combined trig function could go past 2, but when you add this, could go up to 1, the highest this could go is 3. Does that make sense to y'all?
Yeah.
But the reason it never really hits 3 is they don't hit 2 and 1 at the same time because of the period change. Okay, that's not your concern right now because I gave you a graph. 2.1, so it's like this. My point is, suppose I'm stuck or I'm in a hurry in the AP exam, they're about to call time and I've left this one blank, okay? So I come back to it. And this is about 3 by 3, so I know that rectangle is 9, and it may help me narrow down my answer choices. Looks like it's more than half of, do y'all see what I mean? Or at least common sense is my answer correct. All right, so let's move on. I'm going to integrate from 0 to pi, the wonderful blessing of being able to distribute an integral. Distribution is something that we can't normally do, and so I'm very thankful for it when I can. I'll always model for you correct notation. So strive to use correct notation. There's not a 2 in front of this one, sorry. Sine 2x dx. All right, it's a great question. The integral of this one, antiderivative of sine is negative cosine from 0 to pi. Don't neglect filling in 0. Let's go on and finish this one. This is 2 times negative. The cosine of pi is negative 1 minus the cosine, well, I have negative cosine of 0, which is 1. Be really careful with all those negatives going on in there. In fact, let me slow down because I'm not sure I did that right. All right, so this is negative cosine pi minus negative cosine 0. In fact, a little better thing to do is maybe to put the negative with the 2. So I'm not having all these negatives on the inside. So this is 2 times cosine of pi is negative 1. Behind the negative makes it positive. Cosine of 0 is 1. I have minus negative 1. And so this part is 4. Now I'm gonna come over to this part, and you can only integrate things that are simple. Yes, there are some of you that can undo this in your head and compensate for the chain rule, and I'll talk about that after I do it. But right now I'm gonna are y'all watching me sort of kinda?
Yeah.
Okay, so, okay, good. Alright, I'm gonna let U be 2x. Oh, by the way, you can only integrate things that are simple. I'm telling you, U to the third, sine U, ln U, you have no business trying to integrate a composite function, you'll probably mess it up. I don't want you to integrate 2 to the 3x, you can only integrate 2 to the x or 2 to the u. It's got to be simple. Alright, always. So you simplify it on the front end. So here, I'm not going to try to do that one as a composite function, so I'm going to let u be 2x, du is 2dx, 1/2 du equals dx. I'm going to sub with these. So this one becomes the integral of the sine of u, and dx is 1/2 du. My new limits of integration, if I fill in 0, I get 0. If I fill in pi, I get 2 pi. If you change your limits of integration, don't ever go back to x, okay? Alright, the antiderivative of sine is negative cosine from 0 to 2 pi. So I get plus 1/2 negative cosine 2 pi plus minus, top minus bottom, minus negative, so it'll be plus cosine of 0. I think these cancel each other out because the cosine of pi is 1. This will be negative 1 plus 1, so that part didn't even do anything after all that work. But you could have gotten a number there. Was the answer 4?
Yeah.
Okay. Alright, now, the reason I kind of checked on the corner over there to make sure that you're paying attention, because you may have made it through and not needed this problem at all, which is fine with me. I trust you to manage your own time in here. But I am okay after a while if some of you realize with the real easy ones you can compensate with that 1/2. Like I'm okay if you think to yourself on this. In fact, later on, in a few weeks, I'll encourage this so that we can move on, but right now maybe you shouldn't do it. But later, when you have that, maybe you'll reach a point where that is simple enough for you to do. I can't say it enough, so please don't fall for the trap of something like 2x minus 7 cubed. They're going to have 2x minus 7 to the 4th over 4 sitting there waiting on you. They're going to have it waiting on you. Do y'all see what I mean? That's not the antiderivative. You should not be trying to do 2x plus 1 to the 3rd. You should either multiply it out or do substitution. It's a composite function. You could integrate u to the 3rd or x to the 3rd, but not some conglomeration of stuff to the 3rd. Now, here's how I do this one in my head. It's exactly how I just did it with substitution. I'm going to think backwards. Some of them are easy enough to do, some of them are not. This one will eventually probably all do this. The antiderivative of sine is negative cosine. And then you unthink the chain rule, which is what substitution is doing for you. I think if this was a derivative, I would multiply by 2, but it's an antiderivative, so I've got to do everything completely backwards, and I'm going to divide by 2. Okay? Plus C, or put in your numbers. If y'all look up here, that's what it made me do with substitution. Do y'all see that right there? Negative 1/2. I'm not encouraging that right now, girls. You can only integrate things that are simple. So important, okay? And so that's too complicated for you just to go right into integration. It's a composite function. You find yourself falling for those, so be careful. All right, other specific questions? Oh, who asked that question? Was that okay?
Yeah.
Okay.
For number 97, the one where you could use your graphing calculator, I don't know if it was just me, but it took a really, really long time.
It'll take a while for it to compute it depending on what version and operating system you have. And so that is not just you, it's sort of like kind of on there's memes about it and stuff like, I'll just put my calculator over here and go cook dinner and run 6 miles and come back and see what it's. So there's times I let my calculator run and I'll go work on another problem
Okay.
on the test or something like that. So, different, the more slender ones probably go a little faster, Caitlin. But Joe, hopefully you all know what she's saying, you've experienced a little bit of slower. Caitlin, it cannot be programmed to take integrals,
Okay.
because integrals aren't antiderivative. If we know the antiderivative, we will do it that way. If we don't, we gotta go all the way back to Riemann sums. And so it's programmed to be able to do any integration, so it's going all the way back to Riemann sums. That's why it's taking a while, okay? Alright, but that way it can solve anything you give it as long as you have limits of integration. So great question, tells me you really did your homework, okay? Other homework questions? Okay, now I'm remembering before I start the new topic to do this integral. I think it was the same one or similar to one that I ended class with, and I wanted to make myself a note and actually remember to revisit it, which is kind of miraculous. Grace?
Can we talk about 55?
Yeah, let me do that before I do this. Okay, so 55.
I was just confused about whether I should use substitution, if so, which one would be substituted?
I don't see any way to do it without substitution. You might could use an identity. I don't think you could. Tangent to the fourth x, secant squared x. Yeah, I immediately would use substitution even if there's another way to do it. Tangent, if u is tangent, I know right away the derivative of tangent is secant squared x dx. So this goes into u to the fourth du.
So they pretty
Slam
much
dunk.
so they're just like setting it up so you can do it.
You're gonna run into a lot of different things. And so I could run into one that's tangent to the fourth secant x dx, and I would have to use another technique for that. If I had the integral of tangent to the fourth x secant x, I would change this into some sort of secant squared minus 1 and multiply it to the fourth power. I would go through some sort of what we actually call trig substitution instead of, so you just learn to look at everything that comes your way. You spend even more time doing it, so I'm in multivariable calculus. Okay. All right, so kind of brings up the same thing here. The reason I want to do this one is this will happen to you, okay? Suppose this is one on the multiple choice of the AP exam, okay? Or my next test, which a lot of times I think up problems that I like, and this one might be on the next test. One person might think, oh, I'll use substitution. So I'll let u be sine 2x. And by the way, I am going to take the whole entire sine 2x because the derivative of that is some form of cosine 2x. So I see the pieces of my puzzle. I'm not just going to use 2x. Okay? You don't want a product. You're not going to have an anti-product rule except for trying integration by parts. You're not going to have an anti-quotient rule at all. Okay? The derivative of this is 2 cosine 2x dx. Are y'all okay with that? So I get 1/2 du equals cosine 2x dx. And these are my subs.
Sorry, can you go through how you get to u?
The derivative of sine u is, the derivative of sine 2x is cosine 2x times 2. Chain rule?
Oh, just inside. Yeah.
Okay.
I got there.
So now I have the integral of u, and cosine 2x is 1/2 du. By the way, you need to know what I'm telling you for all sorts of different things. Practice on your own when you're studying for a quiz and you're looking at the answers on that live binder thing that I send you, or some of you might use some of the integral calculators, Symbolab and things like that. I hope you found if you want to check some of your Evans or Slater or CalChat or whatever. We're about to get an answer that might not be in the back of the book on Slater or CalChat and the live binder, and then what do we do? So we'll talk about that. Alright, so this is gonna be, 1/2 u squared over 2 plus c. Notice I have to say plus c if I don't have limits of integration. It's called an indefinite interval. Alright, now, anytime you don't have a definite interval, go back to u. So I get sine squared 2x over 4 plus c. That's my answer. I go looking at my answer choices and go, oh my gosh, it's not there. Did I do it wrong? Okay. I spoke about this the other day on a calculator active problems. I'll show you. Okay. Now, suppose that you are sorry, it must be open in the computer, the calculator there. Okay, suppose that your neighbor notices, in fact, like many of the double angle identities, a lot of people don't think of them because it was the last identities you learned. I really, really harp on cosine 2u, like because you need it. But I also know that sine 2u equals 2 sine u cosine u. So probably merely since I've done it forever, when I see sine times cosine, I think of that identity, just like when you see sine over cosine, you think of tangent. I've just done the identity so much longer than you. When I see them divided, I think of tangent. When I see it multiplied, I see that I can make it succinctly into sine. I see a double angle identity when I see sine times cosine. Okay, and maybe that'd be good for you too. Because we can only integrate something simple. Do you see this is too hard to integrate because it's a product? You don't have an anti-product rule. You don't have an anti-quotient rule, and you're not going to get one. Okay, so we've got to simplify it on the front end. One nice way to simplify it is to squish it into just one trigonometric expression. Okay, so I know I can get this into one trigonometric expression. Okay, now right now all I have is sine u cosine u, and so I'm going to say it must be half of sine 2u. Now, granted, you would have to know sine 2u equals 2 sine u cosine u from last year. And you see, if I isolate the product, I have to have the 1/2 on the other side. So I can change this expression to 1/2 integral sine u du. Okay? Now, if u is 2x, what is 2u? 4x. Do y'all see how I use the double angle identity? The reason it's called the double angle identity is sine u cosine u is always half of sine of the doubled angle. So if u is x, that's how you usually saw it in pre-cal, this was 2x. But if this is 5x, this is 10x. Okay? If this is 3x, this is 6x. But now do you see I have a hope of doing it? But it's still too hard because it's a composite function. But I can still get it done now with substitutions. Okay? Girls, don't fall for the antiderivative of sine 4x is negative cosine 4x. Don't forget that 4x is, you've got to compensate for that. So let's try to do it in our head, just so I can move on to what I really want to do today. Antiderivative of sine 4x is negative cosine 4x. But if I was doing a derivative, I'd multiply by 4. So here, what would I do? Divide by 4. Good grace. Also, I could go off and do substitution with let u be 4x, and it would make me do all of that. So now, this person, so this is my first student, got this answer up here. All right, right there. Do y'all see where my cursor is? All right, my second student got this answer. Negative cosine 4x over 8 plus c. And then, then tears start to flow because now I have two students or more that are looking at their answer choices going, I don't know what to do. I've done this problem as well as I can, and guess I'll just guess or move on or something, okay? Then, what about this person that just maybe, I think only this person just maybe wouldn't be thinking clearly, but it's not the end of the world. They could let u be cosine 4x. du is negative sine 4x times 4 using the chain rule. Don't forget your chain rule. Okay?
Why is it 4x? It should be 2x, 4x.
Oh, thank you. Thank you so much. Yeah. Wow, that was gonna backfire. Thanks. Anyway, do y'all see, given the choice, I'd rather let u be sine than cosine because I can avoid the negative. Okay, but I mean, who knows? Sine 2x, cosine 2x, dx. Alright, so I'm gonna let u be cosine 2x, du is negative sine 2x times 2 plus c. Negative 1/2 du equals sine 2x plus c. So I have the equals the integral cosine 2x is u. The rest of it, sine 2x dx, is negative 1/2 du. And so student number 3 gets negative 1/2 u, which is cosine 2x. Oh, I didn't integrate, sorry. Obviously, I'm ready to be finished with this problem. This would give me negative 1/2 u squared over 2 plus c. U is cosine 2x. So I get negative cosine squared 2x over 4 plus c. One of these students would have run into the answer on the answer sheet, okay? The other two would have gone, I don't know, all right? So let's look at it on the calculator and help remember the 4. If anybody was taking notes.
I feel like, why would we put the answers on the answer? I know, but like, don't make it multiple choice then. Like, what's the point?
There's a big point. And even if there's not a point, we kind of, we got to face what we're going to face anyway. So, and let me say this, the critical thinking skills required for calculus is why colleges like to see that on your resume. It's why, whether you major in math or not, people like to see a little bit of math or a lot of math on your resume because they know you can think through situations. I've had speaker after speaker come to my classes and talk about that. Oh, by the way, on Friday, I know some people won't be here. Friday at 8 o'clock, I'll remind you, but if you want to come in, I'd love for some of you to come in and meet the high school that's coming up from Mississippi. But there's also the added bonus of there also another prep alum that I don't know will be coming in. I think it works in fashion design. So you could come and hear a speaker also for free. So I'll let you know. I'd love for you to pop in or out or just come for the whole time. I'll send you an email about whoever this person is and her credentials. I didn't know her. Okay, so anyway, my first answer was sine. Oh, I forget this is not a computer. Okay, so what was my first answer? Sine of what? 2x.
It's sine squared 2x over 4.
All right, squared 2x over 4. And then we can't really compensate for the plus c, can we? Do y'all see what I mean? Like, I could put in plus 7 or plus 5 or whatever. All right, the next one was what? I don't know. What was the next? Negative cosine 4x. Whoa. Cosine. Huh. Sorry, 4x over 8.
Yeah.
Okay, and then finally negative cosine. Oh my goodness. I guess I should do it over here. This will be easier. Cosine 2x
I think it's cosine. Yeah, squared.
squared over 4.
Yeah.
And this plays into some other things. Let's check our mode. We're in radians.
They're parallel.
Yeah, they have the same slope. They have the same derivative. So you wouldn't be able to compare all three, but suppose you just want to know if you did your homework right, and you had one of the answers in the back of the book, or Calc Check had the other answer. You could graph and go, I got the right answer, and you could go on with your life, okay? But if you're sitting on multiple choice, this would be a non-calculator on the AP test, therefore on my test, then what do you do, okay? So I wanted to show you that because it does play into what we were just doing. Are y'all okay that they're just variations of each other with plus C? We don't know what the constant is. Here's another interesting thing. If we actually also had the added advantage that we knew a point that it went through, you see I could decide which one it was?
Yeah.
Because there's a whole lot of wavy lines that you're about to see in a little while. It's this whole bunch of wavy lines or whatever that are a prototype for the real equation, but if I actually knew the point it goes through, we already talked about, it's kind of like pin the tail on the donkey. In this class, is that where we talked about that game, or is it another? Okay. Some people don't remember. All right. So, what if you're on multiple choice, and you get this answer, and you think it might be this answer? Okay. There's a couple of different ways you could go with this. Let me see what I would do. All right, so let's take this answer. There's a double angle identity that tells me cosine 2x, cosine 2u is equal to 1 minus 2 sine squared u. So what would cosine 4x equal? 1 minus 2 sine squared what? If 2u is 4x, then what is u? 2x, isn't it? If 2u is 4x, I can see what's being doubled. Then what is u? This must be 2x. In other words, if this is 6, this is 3, and so on. Now if I rearrange this, I'm going to have 2 sine squared 2x equals 1 minus cosine 4x. And then I'm going to divide by 2. Okay? So 1 minus cosine 4x equals sine squared 2x. Now let's go back up here. Remember that you signed up for this course, okay? I have sine squared 2x. Hey.
I'm dropping off some friends.
Okay.
Hey guys, what's up?
Hi. Welcome. You came at such a great time. Okay. All right, girls, look, stay with me. All right, where did I squeeze that in? Okay, we're right here. Okay, girls, listen. Again, this will happen to you, not a lot, but it will happen, so I wouldn't spend this much time on it. Sine squared 2x is 1 minus cosine 4x over 2. But up here, my answer that I'm desperately trying to find on the answer sheet is sine squared 2x over 4 plus c, okay? So if I have sine squared 2x, remember the over 4. Let's come down here. So if this is true, if sine squared 2x equals this, then what is my answer? Sine squared 2x over 4 equal. Do y'all see it would equal this? I have this problem about, now it's 1 minus cosine 4x, Emma and Caroline, over 8, okay? I see my negative cosine 4x over 8, so I'm ecstatic. I think I'll pick that answer, but I have a problem if I've got this 1/8 in front of it. Who can solve that problem for me? Why am I not worried about that? 1/8 is just a what?
It's constant.
It's just a constant that could be lumped into the other constant. Do y'all see what I mean? Now you do it with me. No, not completely, okay? All right. Hey girls, what's gonna make you think to do that when it happens to you? Notice I didn't say if, I said when. I noticed there's no squared, and so and also, do y'all see that the 4x is there and I was getting a 2x? It makes me think of those double angle identities I'm so high on, okay? All right, back to this. Suppose you have sine squared, and let me tell you what they're going to do to you. They're going to have the negative of that sitting there. And you're going to go, well, I must have just made a mistake. Okay?
I'm not taking you seriously.
All right, but if they have the negative sitting there, and you also see something with cosine squared, and you suspect maybe that's the answer, it's easy for you to change from sine squared to cosine squared. Sine squared is what? What is sine
1
squared?
minus cosine squared.
Okay.
That's the only one.
All right, you girls, look.
Yeah, same.
So sine squared 2x, sine squared u, can be changed to 1 minus cosine squared u. And now I can pick the correct answer choice. Not that one. Now, do you see those match up?
Yeah.
Now, how do they match up? Because this one has this added 1/4 in it.
Yeah.
But that 1/4 could be added to the constant and go, I didn't know what it was in the first place. You see why I needed to go through that with you, because when it happens to you, don't panic. If you have sine, could you change it into cosine? If you have sine 3x, maybe you're looking for a cosine 6x. Please don't panic, just be prepared. I wouldn't let that happen to you without going over it once. Caroline?
Would they give it to us the other way? Like if we get to answer 1 minus cosine squared 2x plus c, and then the answer choice is 1/4 that, and they'll be like, that was the
Or well,
the
then
constant?
the body of it still would have to be over 4. I have to have sine squared 2x over 4. Like I have to have this part. Okay? That the cosine squared 2x has to be divided by 4, or it's not the right answer.
So then what?
I'm just not worried about this extra 1/4 out here,
Oh, okay.
because that 1/4 could be lumped into the constant. Like if I have, let's say if I have x plus 3 plus c,
Mm-hmm.
I just have x plus c.
Yeah. Okay.
Okay. All right?
Mhm.
Because these are indefinite intervals.
Okay.
Rose may be about to ask this, so I hope I don't steal her thunder, but if you're on free response, we're prepared to accept any of the 3. We don't care. Whatever way you worked it, we'll go forward with that. So on free response, or on your homework, I don't really care, but I do think that you need to ask me when you're, quote, really doing your homework, oh, I looked it up on the back of the book and I got a different answer, and if you can't derive that yourself, I'll be glad. We need to talk about it in class some. Identities, you can look at the pre-cal girls in all honesty and go, you better know these things, because you've got to know them for it to even occur to you. All right, other questions? Rose.
If the numbers are simple enough, could you just plug in a number for x and see what
That's
x
also
is?
an idea.
Ooh.
It's a little risky, a tiny bit
Yeah.
riskier with trig functions because of the high repetition of them. And also I've even seen people with polynomials, it's a great idea, but you could be unlucky enough that 2 graphs actually have the same value, but only in one place. But it's a definite great test taking skill. If you pull it off that way, I'm fine with it. At least it can narrow down some things, okay? There's times I filled in a number or done it with somebody I'm tutoring, and at least it knocks out 3 answer choices, and then they have 2 to look at. So, all right, any other I'm sorry, I was doing homework questions. Okay, now, okay, these are so much fun.
Oh, you said that before giving master, we have to know like.
Sine 2x cosine 2x.
Yeah.
So that was it. Thank you. Sorry, I don't have extras, but you probably don't want them here. Yeah. Wait, y'all just, wait, you girls, we just worked this problem, and we call that as having the same slope. So we're now talking about slopes instead of just a slope, because we graduate from lines. So you see there's still parallel. All right.
Oh my god, I love this. I like it. I feel like I'm getting like oh, I love four mazes.
Okay, girls, be very, very quiet. Super quiet. We gotta move fast. You see the headline here, our title is Slope Field, which is kind of hysterical. So they really mean a field of slopes, like a field of corn or a field of cotton. Now, growing up in Mississippi, I was very familiar with fields of corn and fields of cotton. I can smell it right now. But anyway, I think and I say that, I think you also know, as soon as you leave the city of New York, we're pretty much in kind of country kind of situation, so you probably see fields over there. But if you haven't, here's somebody walking through a corn maze that a lot of times, you can even go to them some in the city or right outside the city. They're usually happening Halloween and you're in this maze, you're trying to get out of with scary people chasing you. So anyway, while you're in the corn maze, you're just following the rows that they've cut. Girls, most fields of corn, or you've seen crops probably, or they're done in rows. Okay, and it looks really geometric from an aerial view. If somebody really built a corn maze, I think I've told you my corn maze story. When I first started teaching calculus in Memphis, it got to be October. I moved there in 2003, were you born yet?
yes.
I was
not.
In diapers, when you were in diapers and I was teaching. And they weren't born yet. But anyway, my students, I know, now you're old. Okay, my students were, are you going to the corn maze? And we were in the South, so they said it like the corn maze. You can say maze in about 7 syllables. But Grace's mom and all of her friends that she met would be very, very familiar with the Agri Center corn maze. But I'm looking at them like, no, hadn't done that yet. And they were like, oh, it's so much fun. And you go on Halloween, you pay your money, and you're with your family or your friends, and you go through this maze. You can do the unhaunted one, or you can go at night and do the haunted one where people jump out with chainsaws and blood. And scares me to death, even though I'm thinking probably some of my students are doing it for like a job to earn some money, and they're probably the one with the, It still scares me, even though they're really not going to kill me. But anyway, also, you know me well enough to know that, well, I wish I'd worn my cowboy boots the day I did it, but I wore heels, and so I'm like stuck in the ground trying to like run and crying. I was so scared. I wasn't really crying, but it scares me to death. So anyway, I got to school the next day and like did the corn maze. It was so much fun. Can't wait to go back next year. Blah 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 blah. And they're like, well, did you see it was Elvis? And I'm like, what are you talking about? And they were like, oh, pull it up, online. And so I don't remember what year it was, but anyway, you see they make things out of it.
That's so
Like in the aerial view,
oh, wow.
that was me.
Oh, this is like, you look up the this is sick.
Oh, there's the Grizzlies, Memphis Grizz. But anyway, let me see if I can get Elvis. I don't remember if it was Elvis that year.
That's so impressive.
But whatever it was, they said, whatever. Did I see what it was? And I'm like, no, what are you talking about? And so from the air, they had done all the rows of corn to make things, okay? But, so I always think about that, like when I'm thinking about the corn maze, but when you're in it, you can't really see it until you're in an aerial view. Now, you know, that's cool and all. That would be really hard for us to do, but we're really doing field of corn, field of dreams, field of screams. But we're talking about an aerial view like this, okay?
Yeah.
Is there something bad up here? Oh, these
No, the corn is just.
Whatever.
That's a really large corn.
Thank you. Okay, girls, I don't know what's happening there. We'll have to look that up later. It'll be our slides one day. Okay. Do y'all see how it's a lot like that graph we saw just a little while ago? These are straight. But if for some reason on my field I had to go around someone's property when I was planting the corn, then one row would go like this and go back. The row parallel to that would do the same thing. The row parallel to that would do the same thing, right? Okay, so what you have, these girls walked in and said, oh, slope, okay? What you have when you have an integral, behind it is a rate, is a derivative. It's telling you what your original is doing, but it doesn't exactly tell you what it is. Unless you know I'm on row 7. Are y'all with me? But they're all doing the same thing. So at least it gives you an image of the real thing. You're gonna love this, it's really fun. So we're gonna draw our own corn mazes on here. Are you ready?
Yay!
All right. So look at your sheet.
This giant corn, I want to see.
I know, I'm dying to look at it.
Dublin,
It's in
Ohio.
Dublin, Ohio.
Notice my extreme discipline right now, not getting dragged off into that. Okay, it's taken everything I've got. All right, number 1. First of all, you could argue, and I will argue it with you later, you could argue that I'll just take the antiderivative and I'll know what's going on. But we're not going to always do that, so just watch. When you're asked to draw a slope field, not if, when you're asked to draw a slope field, what you do is, all you have to do, don't overdo it, only draw a slope on the dots they give you, okay? Only draw a slope on the dots they give you. So with girls, you're going to love it. This easy, okay? This used to not even be in the curriculum, which is funny. It's kind of a new thing, but it's so eye-opening. All right, so I have a dot at 0, 1. I'm just starting, you can start anywhere you want to. All right, if I start at 0, 1, what's my slope? Is 1. So you just do the best you can. They're okay with you estimating it. It works out. Now I'm going to go to 1, 1. Hello. You don't want to miss these. They're so easy. So I would write down my points somewhere on scratch paper so you can see them and you don't do too much in your head. I know 1 plus 1 is 2, but I just want to be careful, okay? So x plus 1, I'm doing 1, 1. I don't have a y coordinate in this one. I will in the next one. But 1 plus 1 is 2, so whatever you call 1, make that a little steeper. All right, then what happens when you get to 2, 1, the slope is 3. And then 3, 1, the slope is 4, which is even steeper. Now you can move a little faster that you've realized in this problem, all you really need is the x coordinate. Sometimes the y coordinate will change things, but everywhere x is 1, what is your slope going to be?
2.
So these are parallel through here. You can draw on your paper. At 0, aren't these all going to be 1? Okay. These are all going to be 3 or whatever we decided.
She just said they're all parallel, across are parallel.
Okay. What happens at -1, girls? 0.
Whoa.
Whoa.
Okay. What happens at -2?
Oh, I see.
That took me a
And
second.
you're about to get
I see.
you're about to get an aerial view of our corn maze. Okay. I think these girls up front have already realized what it is.
Oh, I see.
All right. And at -3, I'm going to have -2.
It's gonna be like curvy towards
This is something I can buy.
It's like
This is something I can get like.
You'll be asked to draw
Ooh.
1 or 2 girls. Look up here while you're excitedly drawing your corn maze, okay? And by the way, it's a slope field, but I need to call it the right name. Slope field. Sometimes they'll say, draw a possible solution. I'm so glad I did that sine 2x cosine 2x problem, because I got 3 different looking solutions, but they were all parallel. Do you see how parallel these are?
Yeah.
And so this is a possibility if I'm walking through this cornfield, that it would follow this. Did I catch that right? I think this one goes here. Sorry.
It goes through the middle,
Um,
and then up the.
oh, I'm sorry, I'm missing it. Well, I'm having a hard time doing it myself right
I'm
now.
confused.
Let's see. Oh, I shouldn't be going through that point. There we go.
Yeah.
I
that's
should
what
be going
thought.
through that.
That's what I thought.
Or this one I should be going through here.
And
then
then
zero,
Through the middle.
You forgot the origin.
Yeah.
All right, so let me get rid of this one. So this one would be like this. Okay? All right, they should be parallel. They also, these all look like x squares, don't they? What's the antiderivative now? Let's actually work it. What would y be? We can do this in our head. If we took the antiderivative of that, we would get y is equal to x squared plus x plus c. The vertex of that is negative b over 2a. So the vertex is negative 1/2 somewhere. I'm sorry, I did that wrong.
Oh, it's just like a guess. It's not like it's like what you
Thank you. That, I had no idea where I was going wrong, but thank you, Sophie. The antiderivative x squared over 2 plus x. I was so excited about coordinates. Alright, so the slope is negative b over 2a. Thank God. Alright, so I'm sorry. Did I say slope?
The vertex.
Thank you, Emma.
Yes.
The vertex is negative b over 2a. Time out, pause. You could also take the derivative to find the vertex and set your derivative equal to 0, because shouldn't it give you a minimum where your slope is 0? Can y'all see where my slope is 0? I don't know if you thought about it when I was doing it, but it gave me a critical number. The slope is 0 at negative 1. Okay? But y'all see how it gives you a field of slopes, and we just don't know what the plus c is. Now, if they gave me a point, then I would know exactly which was my particular solution. Okay, so let me go in and show you something here that we're going to be doing sometimes. You can't always do what I'm about to do here. So just sit tight. You can just watch this. I know you're not ready for it really on your sheet, okay? This comes up later on the sheet, but I just want to go in and do it now. There's something, and I want to get the terminology in front of you day after day. They can say, find the particular solution, solve the differential equation, which I told you there's a whole college course that math and engineering majors take called differential equations. You'll hear people call it DiffyQ and DE and all sorts of fancy things. So anyway, yeah. But anyway, you're starting into that right now. It'll say find the particular solution. It might say solve for y. They might say solve the differential equation. All of those things mean I want the original equation. And you can use something called separation of variables. You go back to differentials. You hear all those words, differential equations? So I'm going to call this dy equals x plus 1 dx. Do you see how I separated my variables? Okay? Wow, okay. Girls, you know how when I have a minus, I'm dying to add? When I have something multiplied, I'm dying to divide. Sometimes you just can't help yourself but take the next step. That's what this should occur to you here. Do y'all see that dy and that dx is begging me to take the antiderivative? So I'm going to integrate both sides. Okay? Now what's the answer to this side? X squared over 2 plus x plus c. There was something else. Oh, remember how I said it's going to be important to follow the variable. Girls, follow your variable. This side had a dx. This side has that's a 1 dy. What's the antiderivative of 1? Would be x if it was dx. It would be t if it was dt. But if it's dy, then somebody must have been using a y. So do you see that takes you to the original equation? And then at that point, you could fill in a specific point if they wanted the specific solution. Okay? All right, so let's hurry up and do the second one. All right, so let's do number 2. I tell you what, let's skip. I'll let you do number 2. Let's skip to number 3 because I wanted one with an x and y in it. Girls, I can't take the antiderivative of this one. We can't separate our variables enough to make that happen. Okay, so we're dependent on our slope field right now. So at 0, 0, I get 0. Only do the ones they give you though. All right, at 0, 1, write it down. I get 1. At 0, 2, I get 2. At 0, negative 2, I get negative 2. I'm sorry, it's down here. 0, negative 2, I get negative 2. 0, negative 1, I get negative 1. 0, 1, 0, I get 1. 2, 0, 3, 0. Just do the best you can, it works out. 0, negative 1, I'm sorry, negative 1, 0, I get negative 1. Negative 2, negative 3. Don't go too fast, you want to get these right. At 1, 1, I get 2. So I need to make it whatever I thought 2 was. At 1, 2, I get 3. At 1, 3, I get 4. So it should be a little steeper. You don't have to go back and forth like that. I don't know why I'm doing that.
Do they put these on the exam?
They'll be on the exam. It'll be like
Do the graders really check like?
look at your second sheet.
So it can be multiple.
Those are real free response per third sheet, Carla.
Do they make you like?
And so it all works out. Don't worry about it. So like I can grade, and if I just said everybody do one right now, they'd all look the same. So we don't measure and really see if you got a slope, but we all pretty much know what 1, 2, 3 is happening. Okay, mine are a bit steep here, I think, Carla, when I'm getting the 2s and 3s. So if it's on the exam, I'll probably be a little more careful. All right, or I would be. 1, 2 is 3. I think this one actually is steep. This should be 2. So 3. This is 2, 2, so that's got to be 4. And this is 3, 2, so this is really steep. By the way, going up 1, 2, 3, 4, 5, and over 1 is extremely steep. At negative 1, 1, don't I get 0? At negative 2, 2, I get 0. 1, negative 1, I get 0. So we'll learn to start to look for things because sometimes they say draw a slope field. Sometimes they say pick out a slope field. Girls, make sure that you check assignments. We're not completely matching the syllabus right now, so that's okay. We're in a good place. But make sure you check assignments, okay?
Thank you.
All right, bye girls.